Welcome to ANS Solver question 4. Morgan picks two of these letters without replacement at random. Find the probability that he picks the letter Y first. So, the probability of picking Y, basically we have to find in part A1, because they are asking the probability of finding Y first. So the probability of picking Y would be the number of Y's that there are in the given set of letters divided by the total number of letters. So the number of Y's that are in the word possibility is 1, that is the last letter. So 1 divided by the total letters, that is 11. So 1 divided by 11. This will be our final answer for part A1. Now part A2, the letter B, then the letter Y. So again we do the same thing, but in this case they are asking us for two different letters, and they are asking us for letter B in the first pick and the letter Y in the second pick. So in that order specifically as well, otherwise we would have to do into 2, as we don't know the order, as Y could come first or last. But in this case they are specifying that B has to come first. So the probability of picking a B would be the same probability as picking a Y, as there is only one B out of the 11 letters. So 1 out of 11 multiplied by, because they are asking for B in the first pick and Y in the second pick. Therefore, the AND indicates that you have to multiply the two probabilities. Now, the letter Y. So, the letter Y, the probability of the letter Y we calculated in A part 1. But in this case, there will be a slight change, as they have said that without replacement to calculate the following probabilities. So, if we see, there are only 10 letters left now, as B is removed, as it is already picked in the first go. Therefore, the new probability of Y would be 1 divided by 10. So you can either work this out mentally or input this calculation into your calculator. You will therefore get the final answer as 1 divided by 110. So this will be your final answer for part A2. Now let's move on to A3, where two letters are the same. So there are two possibilities where both the letters can be the same, that is with the letters S and the letters I, as they are the only two letters that are repeating or that have two or more in the word possibility. As you can see over here, there are two S's in possibility and there are three I's in possibility. So only those two letters can be picked twice. So what we will do is, we will first find the probability of picking two S's or the probability of picking two I's. This is because you cannot pick two S's and two I's at the same time, because you can only pick two letters. Therefore, you have to pick either two S's or two I's. Therefore, you have to add both the probabilities. So, the probability of picking an S would now be 2, as there are two S's in the word probability. So 2 divided by the total number of letters, which is 11, multiplied by, because both the letters have to be the same, so letter 1 and letter 2 have to be S. So since there's an AND, there will be a multiplication. So 2 divided by 11, that is the probability for picking an S, multiplied by the probability for picking an S from the new set of letters. So now if you see, one S has been removed. So firstly, now you will write down that there are 10 letters in total. But now if you see, there's only one S remaining, as one S is removed, and they have asked without replacing that S again into the set of letters. Therefore, your new probability of S would be 1 divided by 10. This would be your first half of this answer. You then add the probability of getting two I's. So the probability of getting an I on the first pick would be 3 out of 11, because there are 3 I's, as you can see over here, 1, 2 and 3, and there are a total of 11 letters. This again there are 11 letters, not 9 letters, as the two s's are in the sequence, because this is a different scenario. Therefore there is either or. This is a different scenario, that's why you have to start all over again, as in with you have to start with 11 letters. So 3 divided by 11, the probability of picking an eye on the first go. Now the probability of picking an eye on the second pick. So let's say this one eye has been picked, so let's cross it out. Now there are 10 cards left, or 10 letters left. So you will be choosing out of the 10, therefore 10 comes in the denominator. Now there are 2 eyes left, therefore your new probability of picking an eye would be 2 divided by 10. Now let's simplify the calculation. So if you cancel the 2 and the 10, you will be left with 1 by 5 and 1 by 11. And if you cancel the 2 and the 10 over here again, you will be left with 1 by 5 and 3 by 11. So we can further simplify this as 1 divided by 55 plus 3 divided by 55. So we will be left with 4 divided by 55. Now let's move on to part B. Morgan now picks a third letter at random. Find the probability that all the 3 letters are the same. Now, the only letter that this is possible with is I, as there only I has occurs 3 times in the word possibility, as you can see over here. No other letter occurs 3 times. So Morgan now picks a third letter at random. Okay, so the new probability would be 3 divided by 11 multiplied by 2 divided by 10, again because you are not replacing the card. Therefore the total number of cards would reduce by 1, and the letter I as well would reduce by 1 because you are removing 1. So from 3 there would be 2 eyes left, and in the third pick there would be only 1 eye left, but there would be only 9 cards left as you've already removed 2 of the cards. So let's simplify the calculation. So 2 divided, the 2 cancels out the 10, so 1 divided by 5, and the 3 can cancel out the 9, so 1 by 3 and 1 by 11. So we are left with 1 divided by 11 into 5, which is 55, and 55 into 3, which is 165. This will be your final answer for part B1. Now part B2. Exactly 2 of the 3 letters are the same. So now again there can be 2 possibilities for this, 2 scenarios, which automatically you should register that there should be a plus sign between the 2 scenarios, as the 2 scenarios cannot occur simultaneously or cannot occur while the other scenario is taking place. So one of the scenarios would be that you pick 2 S's and a third completely random letter, or you pick 2 I's and a third completely random letter. So the probability for picking an S was 2 divided by 11, as you can see here. My bad, let's use a darker color. So there are 2 S's, so and there are 11 letters, therefore 2 divided by 11. So 2 divided by 11 multiplied by, when you don't replace the card, now there are 10 cards left, so your total number of cards would reduce to 10, and your number of S's would also reduce by 1, as you've already removed that 1 S. So if you've removed this 1 S, there's only 1 S remaining. Therefore your new probability of picking an S in the second try would be 1 divided by 10. Now For the third letter, we need to pick a random letter. There are, of course, you would know, there are 9 letters left, as we've already picked up 2 cards from before. So, so there are 9 other letters to choose from, and none of them are S. So you can write that 9 divided by 9 as the third pick, as we can choose any of the remaining 9 letters. So this would be your first scenario. Now let's move on to the second scenario, where you choose let's take purple, 2 eyes out of the 3, and the remaining of the 8 letters, because you want exactly 2 of the 3 letters to be the same. So you take the probability of picking an eye on the first attempt, that is 3 divided by 11, because there are 3 eyes and total of 11 cards, multiplied by, now 1 eye is taken away and that 1 eye is a card itself, so the total number of cards reduces to 10 and the total number of remaining eyes reduces to 2. Now for the third pick, we need a random letter that is not I, and there is still 1 eye remaining. But so we know for sure that there are 9 cards remaining, but we can't pick any of the 9 cards. We need to pick 8. So any of the cards other than the I. So the probability of picking any card other than the I would be 8 divided by 9, because there's only 1 I left. Therefore this would be your working for your part 2 or your second scenario. Now, since the 2 letters could be picked either at the first pick or the third pick, the first pick or the second pick or the and the third pick, the second pick and the first pick. It could be picked at any of the 3 picks. Therefore, you multiply each scenario by 3, because there are 3 different ways that you can pick 2 letters in each scenario. So in scenario 1, either the first and the second, the first and the third, or the second and the third. And the same with the second scenario. Therefore you multiply both the scenarios by 3. Now let's simplify this. So 2 divided by 10, we can cancel this out, so this becomes a 5. The 9 and the 9 can be cancelled out to become 1. Over here again the 2 and the 10 can be cancelled out as 1 by 5, and the 3 can be cancelled out with the 9, so as 8 by 3. Okay, now in this case again, now there's a common 3 out, so we can cancel this 3 with the denominator 3 in the second scenario. So what we are left is with 3 multiplied by the numerators in the first scenario are all 1, so we can write 1. The denominators are 11 into 5, so 55, plus this would be your first scenario. Now the second scenario, the numerators are 1, 1 and 8, therefore it would be 8, because 1 into 1 into 8 is 8, divided by 11 into 5, which is 55. Now let's further simplify. So 3 plus 8 divided by 55, so that is 11 by 55. So how I got 3 plus 8 by 55 is I multiplied this 3 with this brackets or with the numerator, so I would get 3 by 55, and hence the denominators are the same, so you can write it together as one fraction. So 3 plus 8 divided by 55 would give you 11 by 55, and you can cancel this, and therefore you'll get your final answer as 1 divided by 5. Now let's move on to the final part of the question, that is B part 3, where all 3 letters have to be different. So we have found the probability in B part 1 and 2 where all 3 letters are the same and exactly 2 letters are different, are same, my bad. exactly two letters are the same. So all we need to do is 1 minus the probability of all three letters being the same, that is 165, 1 by 165, my bad, plus the probability of exactly two letters being the same out of the three, that is 1 by 5. Now I will tell you why I included the exactly two out of the three letters being same in this calculation. If you see, if you do only 1 minus all three letters that are the same, there is still a possibility of two letters being the same, because you haven't taken into account that probability. Therefore you also minus that probability of getting two letters exactly the same out of the three picks in this part of the question, as we need all three letters to be different. So therefore you take into account both B part 1 answer and B part 2 answer in the process to find your final answer for B part 3. So let's solve this. So 1 minus, if you see, 165 divided by 5 will give you 33. So you can rewrite the second fraction, so 165 plus, as 33 by 165. So 1 by 5 is basically the lowest, or the lowest form of this fraction, or the simplified form of this fraction, that is 33 by 165. I have written it like this so that we can work out these two fractions in the brackets. So 1 minus, it would become 34 by 165. Now it would be really easy to work out, as all we need to do is 165 minus 34 divided by 165. So what I did is I rewrote 1 as 165 divided by 165. If you see, that is the same as 1, because if you cancel 165 divided by 165, you will get 1. So 165 minus 34, if you do it mentally, or if you input it into your calculator, you will get 131 divided by 165. Therefore this will be your final answer for part B3.